basic integration rules are just the antiderivatives of your functions. So let's come down here and look at the derivative with respect to x is sine is cosine. Now what that tells you, if I integrate cosine, that's going to give me sine x plus c. Similarly, I know the derivative with respect to x of cosine is minus the sine, so the antiderivative of sine, I have to have this negative sign, so it's going to be negative cosine of x plus c, and that plus c is very important. And you can go on down for all of the trig functions. Similarly, you know that if you have the sum, if you take the derivative of a sum, that's the sum of the derivatives, so the integral of a sum is a sum of the integrals, so that's okay. And I know that if I take the derivative of a constant times a function, that's k times f prime, so pretty much I can always factor constants out of integration, so I'm still in pretty good shape. The ones that tend to be a little tricky is when I integrate k. So suppose I have a constant. I know the derivative with respect to x of k times x is just k. So that tells me the integral of some constant, dx, is just that constant times x plus c. And I'll show you, I'm going to do the generalized power rule here in a minute, separately. Similarly, if I take the derivative with respect to x of a constant, that's 0. So if I integrate 0, this gives me a constant. Now just think about this for a second. The derivative of any constant is 0, so you have to make the allowance that c could be 215. Now finally, let's come down here and look at we're going to call the generalized power rule, or just the power rule. I know the derivative with respect to x of x to the n is n times x to the n minus 1. So I take the power and I multiply and I lower the power. Integration is the inverse of differentiation. So if I integrate x to the n, instead of multiplying by the power, I divide by the power. Instead of lowering the power, I raise the power. And I do have to put the caveat that n cannot equal -1. So let me come over here and do this one separately. The derivative with respect to x of x to the n is n x to the n minus 1. You're fine with this. Now let me show you that if I integrate x to the n, dx, this is x to the n plus 1 divided by n plus 1 plus a constant. Now let me show you by taking the derivative with respect to x of x to the n plus 1 divided by n plus 1 plus c. What is this? Well, this is going to be n plus 1 times x to the n plus 1 minus 1 divided by n plus 1. And the derivative of constant is, of course, 0. So this becomes, the n plus 1's cancel, x to the n. So the antiderivative of x to the n is x to the n plus 1 divided by n plus 1 plus c.